Okay, so in the previous video lecture, I asked you that question, how to make a better world and what were the best traits that you will put in the new generations, how you make the perfect Canadian. And you know, that is a very difficult answer. But what Galton thought is, what about if we take all these best traits of all the best people, of all the things that we love, and we promote that these people have children, and as we marry these people, we avoid that they dilute those best traits. And that was very controversial. So he was trying to make a better world. And if you remember the examples of the corn and examples of the artificial selection of the corn and of the different type of animals, he said why we don't do the same thing with humans. And although it was a novel idea, let's say in the beginning, it create terrible consequences. And actually, those ideas, unfortunately, were used by politicians, as I will show you, and they end up even in the generating the Second World War. So let's talk about that. So we're going to talk now in this section about social Darwinism. So Galton was very interested in applying the ideas of Darwin into human evolution. And as we watch in the video, I want that you remember the examples of twins. I want that you remember, and I will show you videos about the Anthropometric Lab, that was something very positive. This is how human genetics start. And later we will talk about the problems of Galton's work. That, as we talked multiple times, is eugenics. So let's start talking about. So in the Victorian era, and in particular Galton, although there was not invented the word even genetics, and we don't know where the genes were located, the idea is that school of thought considered that being smart and other phenotypic traits, they have a huge influence of nature, while the environment play a very low influence. So, for example, a phenotypic trait like being smart, like eminence for Galton, it was due to heredity mainly, not to the environment. So he then thought that maybe the people that was not very smart, it was because they didn't have the proper education, or there was a correlation between the socio-economical conditions and the intelligence. So, and more than doing this on purpose, he was just biased because, as I said, of his family and the hierarchical organization of the British society of the Victorian era. So, to summarize, Galton have a very deterministic view of genetics. So, and as we watch in the video, so he thought that the characteristics in biology, they must be shaped by genes rather than the environment or experience. And this is something very characteristic of this Western school of thought. And as I said before, he said, okay, now all that Darwin have explained, are the implications for our society? And Galton's ideas start diverging from the ideas of Darwin's. And one example of that is the study of twins. And the study of twins that Galton had clearly showed the personality of Galton. So, first, he was a pioneer on a field that he was the first one who did the study of twins to measure the relatively strengths of heredity and environment. So when he studied twins, he started comparing these two factors, heredity and environment. But how he did it? He did it in a very systematic way. So something good of his study is that he collected a lot of data and he was able to compare it. And the idea of his studies was to establish how far similarities and differences between twins were affected by their life experience. And you know that in that case, twins are a great example because we can clearly see what happened in the environment, what is the results of the environment, and what is the results of the genes. Of course, he still didn't know what was a gene. He still didn't know so many things, but it was a good beginning, to human genetics. And as we watch in the video, he started one of these debates between nature and nurture that are very common in psychology and in biology. And nature in biology will be genes, while in nurture will be the environment in biology. So he was trying to try to see if nature was more important, genes were more important, or the environment was more important. In his case, he found that nature was more important. And to finish this idea of twins, of the work of Galton, I just want to tell you that his work on twins was helped me to explore the idea of acquired inheritance, and he found that he rejected the idea of acquiring inheritance using twins because, as we talked just in the previous slide, the environment in his case he didn't play a key role. So independent of the environment where the twins were located, they will have the major influence will be the nature, the genes, not the environment. So he rejected the idea of the acquired characteristics, and in contrast, he argued that the hereditary material was exclusively stored in reproductive organs, and those ones were isolated from the effect of the environment. And to some degree, this is true, although, as we have talked before, the environment in the last decades, this idea of the importance of the environment has increased, and now we know that depending on the trait, the environment can play a much important role than in other cases. Okay, so now we just finished talking about the twins, the debate between nature and nurture, and if I ask you in a test, I want that you tell me that for him, nature was very important, while the environment, the nurture, was less important. And how he studied that? Study twins, and using that, he reject the idea of acquired traits. Now I want that we talk about the anthropomorphic lab. That it was, again, in the same way that the study of twins was very important, then the study of anthropomorphic lab, it was the beginning of human genetics. And to move into the anthropomorphic lab, Galton was so interested in statistics that he saw biological traits as data points, that it was very revolutionary for that time. So if you remember these experiments with Galton used sweet peas to measure different traits, and he was very interested on this type of behavior, that they always have this bell curve. So he was interested in why do you find always that there is an average, and what is the implication into other traits. So he didn't know why, but he found that traits follow a normal distribution. And I'm going to show you a video that talk about the importance of his work and the importance in particular of these normal distributions. Again, in this video we will talk about another of the applications of Galton's work, and this is very interesting because it's not only has an application in genetics, but also has an application in finance, and they will show you a very interesting machine that he created. So I hope that you enjoy this video too.
One of the most important concepts for investors to understand is reversion to the mean. It's also widely used in statistics. The phenomenon was first observed by Francis Galton in the early 1870s. And this is the machine he designed himself to illustrate it, variously called the Galton board, probability machine, or quickuncs.
It has got his handwriting on it, and his handwriting is a set of handy instructions as to how to use the device. You have to turn it topsy-turvy, as he said. As I let it go, all the little ball bearings feed through the funnel, and they're channeled through the quincunx pattern of nails, and there at the bottom, every time you do it, you get the normal distribution, or the bell-shaped curve.
So why the bell-shaped curve? Well, it's all to do with what mathematicians call binomial distribution.
For every single one of the balls, whenever it hits one of the pins, it's got a 50-50 chance of going one way or the other. And what the device demonstrates is that the odds of one of the ball bearings hitting pins and constantly going to the right, for example here, is considerably less than the odds of it travelling and coming into the middle. Why Galton was interested in this was because he wanted to understand about the laws of heredity and how traits are passed from parents to their children. This bell-shaped curve became rather iconic when a Belgian statistician called Adolphe de Kettelet observed that if you measured for an individual trait within a population, you always got the bell-shaped curve.
Investment author Mark Hebner believes Galton's machine is an excellent way of illustrating stock market returns, so much so that he commissioned a large replica which takes pride of place in the office of his firm, Index Fund Advisors, in Irvine, California.
One of the results that's really interesting is going forward, you should anticipate about half of those returns being greater than the average expected return and half being less than those returns. And the further your return ends up being from the average, the less likely it is to occur.
Now that you watched that video, now I'm going to show you another finding, another approach that it was very important, that actually started the field of human genetics, and it's this obsession of Galton for counting and quantifying things. And it's the Anthropometric Lab. So he was obsessed with seeing difference between humans, what is not wrong, yeah? So for example, he tried to look for difference between cultural groups and between people within a culture. So for example, he started trying to measure the skull, how big they were the skulls, what was the curvature of the skull, the type of the color of the hair, the color of the eye, the time of reaction. They see something, how fast you react to those changes, and he started trying to quantify those things, what is actually very useful. So remember, his goal was to evaluate difference between humans using precise measurement. And this started the field of psychometric, which is defined as the application of statistics to measure individual reference with reference to behavioral variables. However, there was a problem with this. All these measurements, so for example, to have a small or a big head, it doesn't mean that you are, or to have a shape of the skull in a certain way, that it was something that it was actually believed for decades. It doesn't affect the intelligence. What actually affects intelligence is more the connection between your neurons, is to have a specific genes. And actually, to be honest with you, we are still working on what is intelligence, and we are still working on a lot of things. So although quantifying was correct, the analysis and the implications that he found were not correct, because nobody at that time knew what the shape of a skull. It doesn't mean that you're more intelligent or less intelligent. There were other traits that they were more important to determine if somebody's intelligent or not, and we are still working on that. And here there is a picture of the Galton's lab and all the inventions that he created, and actually he showed that in an exhibition, and he started asking people for money. So he did start measuring the skull of the people, the shapes of the skull, the fingerprints, a lot of things. He started charging for that. So people found that very interesting, and in that way he collected money to do more experiments. So remember, he introduced the anthropometric labs in 1884. I will not ask the date. and he showed all the equipment of his own invention. And in that way, he started testing mental abilities, and he started collecting difference between each people that were taking those tests. Again, although the data was correct, it was wonderful to have that data. The analysis that he had, they were not. He didn't have the basis to make connection between the thing that he quantified and intelligence. And again, as I said before, he was the one who started having these fingerprints, and he found that they were a good way to differentiate between people. And I'm going to show you some example of the measurement that he did. So he measured, for example, the body measurements and the muscular strength. He also measured the sensory capacity, and in this way, he determined if somebody was more intelligent or another one. And how he did it, he discriminated between different intervals of pitch, so how fast somebody can perceive some pitches, and also the reaction time. And I will ask this in the test again, the name of this book, and what he implied in this book. He found two main findings. One, that the behavioral and mental traits could be inherited, what is partially true, and the difference between individuals could be measured, what could be partially true. However, in the way that he did it, it was not correct. So, but it was a good beginning to start analyzing difference in intelligence and morphometrical difference in humans. However, there was no connection between the difference that he analyzed and intelligence. And as a result, he concluded that outstanding ability can be inherited. Later, I will show you some ways in which these things went really wrong. And this was one of the type of proof that he showed for his argument. He select men of outstanding ability, and he looked at the frequency of success among the relatives. So, for example, 30% of illustrious fathers, in those cases, they have 48% of having an eminent sons. So, if your father, he considered that his fathers were very smart, their kids will also be, it's very likely that they will be very smart. Now I'm going to move in the problems of Galton's work. That, of course, it was this that we already talked to, eugenics. So one of the problems is Galton's use a restricted sample. For him, for example, he never included women because at that time there was a bias for gender. And not only that, class was very important, and he never included businessmen from industry or commerce. He only included people that he was related to the queen or people that he was very rich because of his position in the society. So he overemphasized heredity factors under environmental factors, as we have previously said talked during this lecture. And I just remind you that education was compulsory in 1880 in England. So in the time that Galton lived, many people didn't have any education, and the profession, your professional career, will depend mainly on your connections. So if you were brother or you knew somebody that it was related to the queen or related to somebody famous, you will be able to have not only a better education, to a better place for entry jobs. So he then took that into account, and this also biased his data. Now I'm going to stop in this section. I'm going to talk a little bit in the class more, and I'm going to show you how this eugenics was took by politicians and how those politicians end up turning these scientific ideas in something really bad. And hopefully we can have a nice discussion and about the importance of science and discoveries and how they should be communicated to the society.